So consider a vector field A. So this vector field A is again AX x cap, AY y cap, AZ z cap. And in this vector field, we have to find curl. So curl again we have to define at a particular point. Just like divergence you have to find at a particular point. Similarly, you have to find curl at a particular point. So curl is given by, del operator. So if you find del cross A, that represents the curl of a vector. And how to calculate this? You can easily find in Cartesian coordinate, x cap, y cap, z cap. So this will be del x, del y and del z. And this is ax, ay and az. So you can easily expand this. Curl of A, so x cap component is minus del ay by del z minus y cap and then z cap component is given by del ay by del x minus del ax by del y. So you can easily find curl in a Cartesian coordinate system. Just put ax, ay, az and expand this. You will get curl of a vector. And you have to find this at a particular point, let's say A, B, C. Some point is given, so you will get curl of A. Now you have to see what does curl represent. So this is the mathematically you can find the curl, but we have to see what does curl represent. So again we will see some simplest case of a vector field which we can represent also. So let us take that vector field. So vector field A is, you can take it as minus y x cap plus x y cap. Let us take this vector field. Now we have to represent this vector field. So take it as x and y direction. Now first consider 4 points. This is 1, 0. This point is 0, 1. This point is minus 1, 0. And this point is 0, minus 1. So let us first represent vector A at these 4 points. And then we will represent at some other point also. So at 1, 0, when point is 1, 0, how to write vector A? Put x is equal to 1 and y is equal to 0. So this will give you y cap. Simply y cap. At 1, 0, vector A is y cap. At 0, 1, vector A is, at 0, 1, vector A is, put x is 0 and y is 1. So this is minus x cap. Then at minus 1, 0, vector A is, again x is minus 1. So this is minus y cap. And fourth point is 0, minus 1. So vector A is, x is 0, y is, so this will be x cap. So if we represent at 1, 0, let us, in each case magnitude is fixed. Let us take that magnitude is 1. So at 1, 0 direction is y cap. So let us assume this magnitude is
Hello, sir.
1.
Hello, sir.
Yes.
Sir, please explain again.
You have to, I have taken this vector field. Now I am representing this vector field. So if you want to represent this, let us first choose 4 point and represent that vector. So when you take point 1, 0, vector A is y cap. You can just check it, y cap, put x is 1, y is 0. So you will get simply y cap. Similarly at other point, vector field is A is y cap, this is minus x cap, minus y cap and x cap at different point. So at 1, 0, y cap. So I have represented by this magnitude, direction is y cap. At 0, 1, minus x cap. So same magnitude, but direction is minus x cap. So this is minus x cap. At minus 1, 0, minus y cap. So this direction is minus y cap. At 0, minus 1, x cap. So this direction is, so you can see arrow. Similarly, if you take other point in between, you will get this form that you have to plot at different point. So I have taken this vector field just to show you there is rotation of a vector around a given point. That's why I have taken this example, just to show you around a given point vector it has rotation at a different point. So similarly, if point is 2, 0, let's take, if you have point is 2, 0, what will happen? Only magnitude will be double. Now this magnitude will be 2. Similarly, if it is 2, this magnitude will be 2. This magnitude will be 2. This magnitude will be 2 in this form. So you can represent this vector field. So this is the vector field. Similarly, if magnitude is 3, you can take this magnitude will be 3, 4, magnitude will be 4. So you can represent a vector field in xy plane. So that is vector field minus yx cap plus xy cap. Is it clear? Our purpose is not to draw this, just to show you what does curl represent. I have taken this example and I have also represented it. So you know how to represent it also. Take another example. Vector A is x, y cap. Let us represent this vector field also. X, y cap. Represent vector field x, y cap. So in this case, let us consider, take it as x, this is y, and this is z. Now you can see when x is positive, direction is y cap. So we can represent this direction as x is positive, direction is y cap. And when x is 1, magnitude is 1. When x is 2, magnitude is 2. When x is 3, magnitude is 3, and so on. You can easily plot this. And similarly, when x is negative, direction is minus y cap. Direction is minus y cap.
सर एक बार ये डायरेक्शन वाला रिपीट कर दो.
Just see this vector x y cap. What does it mean? When x is positive, direction is y cap. So x is positive, direction is y cap, and as x increases, magnitude of the vector is increasing. x1, x2, x3. Similarly, when x is negative, so minus y cap, then you have,
opposite हो जाएगी.
ठीक है? Magnitude is also doubled. So this is the vector field. You can represent this vector field. So I have taken these two examples so that you can represent the vector field also. Now you have to find curl in these two vector field. Around a given point, let us calculate curl around the point. So mathematically, just find the curl. In both case, find curl of A. Let us find curl of A. In this case, just substitute AX is minus Y, AY is X, AZ is 0. Then expand it, you will get del cross A. What will be curl of A in this case? Just substitute here. AX is minus Y, AY is X, and AZ is 0. Expand this, you will get curl of A. ठीक है? What will be curl of A? This is 2Z cap.
2Z cap.
2Z cap. Just check it, you will get 2Z cap. And in this case, put AX is X, AX is 0. In this case, AX is minus Y, AY is X, and AZ is 0. And in this case, AX is 0, AY is X, and AZ is 0. So AZ is 0. If you
Sir,
expand,
how del cross A is equal to Z cap?
yes,
Del cross A is equal to Z cap कैसे है सर?
इसमें सब्स्टिट्यूट कर लो. ये तो आप कर सकते हो. ये यहाँ पे सब्स्टिट्यूट करके आप देखो क्या होगा. एक्स कैप कंपोनेंट इसका क्या हो जाएगा? 0 माइनस 0 माइनस वाई कैप क्या हो जाएगा? 0 माइनस 0. अब देखो जेड कैप कंपोनेंट क्या होगा? जेड कैप लोगे तो ये 1 हो जाएगा और ये माइनस साइन के साथ ये भी 1 हो जाएगा. दैट इज 2z कैप. Just substitute AX, AY, AZ. I have written here. In this formula, substitute it, expand it. You will get. So this is
Okay, sir, got it.
This is 2Z cap, and similarly you will get here Z cap. ठीक है? Now you can compare these curl in these two vector field. As you can see, curl has magnitude and direction. So direction in both cases same, so that you can easily compare. Now you have to check for magnitude. This magnitude is 2 and this magnitude is 1. So if you compare these two field, you can see this is the reason of high curl. Here you have high curl as compared to this vector field, because its magnitude is 2 and its magnitude is 1. So in a sense, curl represents rotation of a vector around a given point. How a vector rotates, mathematically you can calculate from this relation in Cartesian coordinate. In last class, we have discussed that divergence is spreading around a given point, and curl is how a vector rotates from a given point. And we have to see curl in terms of field. So in terms of field, if curl is non-zero, then field forms a closed loop. For example, magnetic field. You know that magnetic field forms a closed loop. So you will see in magnetic field curl is non-zero. And if curl is 0, then there is no rotation of a vector around a given point. Around a given point. Example is electrostatic field. So you will see in magnetic field forms the closed loop and curl is non-zero. But in electric field, in electrostatic field, you will see curl is always zero. So electrostatic field is a region of high divergence but zero curl, and magnetic field is the region of high curl but zero divergence. So you have to see divergence and curl in terms of field, and mathematically you can calculate in this form. In last class, I have discussed this vector field also. That vector field A is RR cap or XX cap plus YY cap plus ZZ cap, and that I have plotted it around a given point. Let us again plot it. I have discussed this vector field. This is the vector field A, XX cap, YY cap, ZZ cap. So now you have to compare between divergence and curl, which is the region of high divergence and which is the region of high curl. So just focus on these 2 points, these two vector field. In this vector field, I have already calculated curl. Let us calculate divergence in this vector field. Calculate divergence in this vector field. What will be divergence? So AX term is Y, so this will be 0, and AY term is X, so this is also 0. So divergence will be 0. So this is the reason of high curl but zero divergence. In this case, in last class I have calculated divergence of A, that will be 0. Now calculate curl of A. This is 3. Divergence of A is 3. But now calculate curl of A in this vector field. Let us calculate curl of A in this vector field. Find curl.
0.
Curl is 0. So in this case, curl is 0. So you can see this is the region of high curl but zero divergence, and this is the region of high divergence but zero curl. So you can easily differentiate between divergence and curl. Is it clear?
Sir, how we find the direction of rotation?
That you have to calculate. This direction is Z cap. So this is in XY plane and its direction is Z cap and magnitude is 2. That you have to calculate, and this you have to plot it from the vector field, and you will see when it is rotating in anti-clockwise direction, you will get direction is along Z cap. That you will get. So that rotation in anti-clockwise direction, and you are getting this in a clockwise direction, in a Z cap direction.
Z cap. Okay, sir.
So that you have to calculate mathematically.
Sir, in this question, is this minus y x cap plus xy cap? I mean,
there are different examples. Just to explain you, I have taken these two simplest case. For any hypothetical case, mathematically you can calculate, but I cannot plot everything to show you what does divergence and curl represent. That's why I have taken example of a electric field and magnetic field. And from these two,
सर वो
How
कैप
you have
शो नहीं कर रहा है
written,
सर.
Which
yes,
this
sir.
this
How
cap?
you have written?
This
yes, sir,
is
दिख नहीं रहा है. That's why I asked
this
you.
is minus x y cap plus this is minus x y cap plus y x. I think this is minus y x
minus y x cap.
plus x y cap. ठीक है? So now we will see how to find curl in spherical, polar and in cylindrical coordinate. So again you have to remember formula for curl in spherical, polar and in cylindrical coordinate. So in spherical polar coordinate, this is AR r cap, A theta theta cap and A phi phi cap. So curl of A is given by, this is 1 by r square sine theta, this is common term, and then you have to expand this determinant. This is r cap, then you have r theta cap and r sine theta phi cap. This term is del r, del theta and del phi, ar, r into a theta, r sine theta, a phi. So you have to expand this, and finally you have to multiply with this term 1 by r square sine theta. And in this formula, you have to only replace for AR, because in spherical polar coordinate, AR, A theta and A phi is given. So just replace it, you will get curl of A in spherical polar coordinate. And in cylindrical coordinate, this is AR, R cap, A phi, phi cap, A Z, Z cap. So vector A is given in cylindrical coordinate, you will get del cross A, del cross A is 1 by R, R cap, R phi cap and Z cap. So this is del R, del phi and del Z. AR, R into A phi and AZ. So in this case, you have to multiply with 1 by R. And in this formula, substitute for AR, A phi and AZ. ठीक है? So let us see one example in spherical polar coordinate. So vector A is given. Example is, this vector A is given. This will be R cos square theta R cap minus R cos theta sin theta theta cap plus 3R phi cap. This is vector A in spherical polar coordinate. So in this formula, we have to substitute for AR, A theta and A phi. So this term is AR, you will get AR, A theta and A phi, and then expand it. So what will be del cross A? 1 by R square sine theta term is common. This is R cap. So if you differentiate with respect to theta, so you will get del theta into R sine theta into A phi is 3R, and minus del phi into R into A theta. So A theta is minus R cos theta sin theta, So this is the term for r cap. And then you have to see minus r theta cap term. So minus r theta term is del r sine theta into a phi. A phi is again 3r and minus del phi into ar. This is r cos square theta. And then last term is plus r sine theta phi cap. So this will be del r into a theta. So del r into a theta. A theta is minus r cos theta sine theta. And then del theta into ar. So ar is r cos square theta. Close this. Now you have to differentiate it. So let us differentiate it. So first term is 1, this is common term, 1 by r square sine theta. What will be this term? This will be 0, and this term is 3 r square cos theta r cap. This term will be 0. Then minus r theta cap. What will be this term? 3r square will give you 6 r sine theta minus 0. And last term will be, this term will give you r sine theta phi cap, and this common term is, if you differentiate with respect to r, you will get minus twice r cos theta sine theta, and this will give you minus twice r cos theta, and this will give you sine theta. So that is cancel out. This will be 0. So if you divide it by r square sine theta, you will get 3 cot theta r cap and minus 6 theta cap. So this is the curl of A. This is curl of A in spherical polar coordinate. This is curl of A. Okay? So in this formula, you have to substitute for AR, A theta and A phi. Is it clear?
Yes, sir.
So if you know AR, A theta and A phi, just substitute here. And finally, remember that you have to always multiply with this common term. So let us make circle it. Next example in cylindrical coordinate. So you have twice r cos phi r cap plus r phi cap. You have to find curl in cylindrical coordinate system. So in cylindrical coordinate, AR is twice r cos phi, A phi is r, and AZ is 0.
Okay, sir.
So now find curl of A. So in this formula, you have to put for AR, A phi and AZ. So 1 by R term is common. Then R cap will give you del phi AZ. AZ is 0 minus del Z R into A phi. R into A phi is R. Next term is minus R phi cap. So minus R phi cap will give you again del R into AZ is 0 minus del Z into AR, and AR is twice R cos phi. And then this Z cap will give you del R into R into A phi. This is R minus del phi into AR. AR is twice R cos phi. So this term, this will be 0 and this is also 0. These first two terms are 0. Now last term is plus Z cap. This will give you twice R and this will give you plus 2R sin phi. Then curl of A is 2 plus 2 sin phi Z cap. So this is curl of A in cylindrical coordinate system. Is it clear?
Hello, sir.
Yes.
Hello, sir.
Yes.
Sir, आपने डेल अपॉन ओके सर क्लियर है.
Just expand this. I have substituted AR, A phi and AZ. Then expand for R cap, R phi cap term and Z cap term. So R cap, this minus R cap, this minus this, Z cap, this minus this. Take AR, A phi and AZ. I think it is clear.
Yes, sir.
Just substitute for AR, A phi and AZ and expand it, you will get. So you know how to calculate curl in Cartesian coordinate, spherical polar coordinate and cylindrical coordinate. So we have discussed how to find gradient, divergence and curl in different coordinate system. And these are the first derivative. We need some second derivative also. So let us
Sir?
see. Yes.
The last value is Z cap R into del by del R into R.
So Z cap is del R into A phi. You can see R into A phi. This is
And
R
the value
into
of A phi is
A phi is R. You can see A phi is
the
R.
derivative is 1.
Derivative with respect to R will be 2R. This is 2R. So I have written it here 2R. And this
Okay.
cos phi will give you minus sin phi. So this is 2R sin phi. Then divide with R. You will get 2 plus 2 sin phi.
Okay.
Okay?
हेलो सर.
Yes.
सर ये R क्रॉस R है या R into R है?
Where R into R. What is R cross R? It's not a vector.
Okay.
That is multiplication.
Okay, sir. Okay.
Okay? So now we will see some second derivative. So second derivatives are, we will mainly talk about 5 second derivatives. So let us see some second derivatives. Some second derivatives. So first is divergence of a gradient. Divergence of a gradient. Because gradient is a vector quantity, so again you can find its divergence. So how you will define? Del dot gradient V. This defines the divergence of a gradient. So we can write del dot del is, you can write del dot del, this you have to operate on V, so that is del square V. So del square V is written as so this is the Laplacian operator. Del square is the Laplacian operator. So you can easily find in Cartesian coordinate. Divergence of a gradient is del square V. So if V is given in Cartesian coordinate, you can easily calculate using this relation. We have to also find del square V in spherical polar and in cylindrical coordinate. So if V is given as a function of r theta phi, let us see, V is in r theta phi. So what will be del square V? Again you have to remember this. This is 1 by r square del r into r square del V by del r. 1 by r square sine theta plus 1 by r square sine square theta del 2V by del phi 2. This is del square V in spherical polar coordinate. So if you remember these terms, just substitute V and then differentiate it, you will get del square V in spherical polar coordinate. We can also find del square V in cylindrical coordinate. So in cylindrical coordinate, del square V is 1 by r del r r into del V by del r plus 1 by r square so this is del square V in Cartesian coordinate, in spherical polar coordinate and in cylindrical coordinate. You will see in Poisson's equation, when we have to find charge density, we will use this relation. Del square V is minus rho by epsilon naught. So if potential is given, you have to find charge density, you can directly use this relation. And we will also talk about Laplace equation. Sometimes you have to solve, that is del square V is 0. So you can easily calculate divergence of a gradient or del square V. Now in this case, I have operated del square on a scalar, but you can operate del square on vectors also. For example, if you have a vector field A, that is AX x cap plus AY y cap plus AZ z cap. So we can operate del square A in this form. Now you have to operate this in component form. Del square AY y cap plus del square AZ into z cap. So whenever you have to operate del square on vector in Cartesian coordinate, you have to operate in component form. You cannot use same in spherical polar and in cylindrical coordinate. You have to always convert vector in Cartesian coordinate, then you can operate this. So this is valid in Cartesian coordinate only. You have to operate in component form in Cartesian coordinate only. In Cartesian coordinate only. If vector is given in spherical polar or in cylindrical, first you have to transform that vector in Cartesian coordinate and then you can find del square A. So you can operate del square on a vector in Cartesian coordinate. Is it clear?
Yes, sir.
So you have to remember this relation. Now second is, what will be curl of a gradient? You can also find curl of a gradient. You will get curl of a gradient. You will get curl of a gradient. So that is, what will be del cross gradient V?
0.
This is
Zero,
always
sir.
this is always 0. You can easily expand because gradient V is, it has three components, del V by del X, del V by del Y, del V by del Z. So if you expand this, you will get X cap, Y cap, Z cap, del X, del Y and del Z, and this will be del V by del X, del V by del Y and del V by del Z. You will get this is 0. So curl of a gradient is always 0. Curl of a gradient is always 0. So if curl of a vector is 0, sometimes, let's say if curl of a vector is 0, it means we can always express this vector as gradient of some scalar function. You can always express vector A as gradient of some scalar function because curl of a gradient is always 0. ठीक है?
Any coordinate system it is valid, sir.
That is always valid. Curl of a gradient is always 0 in every coordinate system. Now third is, you can also find gradient of a divergence. Gradient of a divergence. Gradient of a divergence. So that is given by divergence of A is a scalar value and then you can take gradient. So you can see this is not equal to del square A. This is not equal to del square. Del square A is del dot del. So this is given by del dot del and then you have to operate this on A. So you have to separately calculate gradient of a divergence, and this is not equal to del square A. ठीक है? Now fourth is divergence of a you can also find divergence of a curl. Divergence of a curl. So if you expand this, again you will see divergence of a curl is always 0. So first find curl of A and then take divergence, you will get divergence of a curl is always 0. It means if divergence of some vector is 0, it means we can express B as curl of some other vector, because divergence of a curl is always 0. So if divergence of some vector is 0, it means you can express that vector as a curl of some other vector, because divergence of a curl is always 0. ठीक है? And last one is, fifth one is, you have curl of a curl. Curl of a curl. So you have to remember this expansion. We will use it. Curl of a curl. So that is given by gradient of divergence of A minus del square A. So just remember this expansion. We will use it. Curl of a curl can be expressed as gradient divergence A minus del square A. So we will use these 5 derivative also, 5 second derivative also. Gradient divergence curl, they are the first derivative, and these are the second derivative. Is it clear?
Yes, sir.
So in last class, in case of gradient, I have discussed one example in which I have shown you how to find maximum or minimum point. So we have to see under what condition you can check whether these points are maxima point, minima point, or sometimes there is another point known as saddle point. So I will just give you how to check it. Okay? Because using second derivative you can check it. So just note down. We call it as second partial derivative test. That is for maxima, minima, or saddle point. ठीक है? So first step is, if some, let's say some scalar function is given, f is function of xy. This is given. In our example, I have taken h is the height, that is function of xy. So for maxima and minima condition, you have to first put gradient of f should be 0. This is the condition. And then you have to find points. You will get points. Now on that point, you have to check whether they are maxima, minima, or saddle points. So what you will do, check for second derivative. let us say del 2 f by del x2. So if this is positive value and del 2 f by del y2, that is also a positive value. In that case, just like in one dimension, if positive value, function will be minima or maxima?
Minima.
Minima or maxima?
Minima.
Minima. So you will get minima here. And if these values are negative, then you will get maxima. And when one is positive, another is negative. Let's say one is positive and another is negative. In that case, saddle point. Saddle point is neither minima nor maxima, because in one direction it has maxima and in other it has minima. So we call that point as saddle point. But there is exception to this rule also. For this rule, there is one exception. Sometimes there is exception also. So for final conclusion, you have to do another test. So that is the final test. For normal cases, this is valid, but sometimes exceptional case, final test. So final test will decide whether your condition is right or wrong. So in that case, let us find H. H is, I will represent this partial derivative by f(x)(x). Let us represent this and represent this by f(y)(y), and then you have to find this value f(xy) also. F(xy) is del 2 f del y del x, or you can say f(y)(x) is del 2 f del x del y. So in this case, you have to find f(x)(s). Let's say that point is x0 y0, then into f(y)(y) x0 y0 minus find out f(xy) at x0 y0 whole square. You have to find h. This is f(x)(x) f(y)(y) minus xy or yx whole square. If h is greater than 0, in that case, that point is maxima or minima. And you will check maxima or minima just by saying if positive, minima, if both are negative, maxima. And if h is less than 0, then that is the saddle point. So just remember this condition. You can always verify. So in this example, function f is given, that is x power 4 minus 4x square plus y square. So you have to find, first you have to find points where you will get maxima, minima or saddle point, and then you have to check at that point. So have you tried this question? So you have to equate gradient f to be 0. So separately you have function del f by del x must be 0. So what will be del f by del x? This will be 4x cube minus 8x is 0. So this will give you, take 4x common, x square minus 2 is 0. So this will give you x is 0 and other will give you plus minus root 2. So that is point x. And second condition is del f by del y is 2y and this will be 0. So that will give you y is equal to 0. So these are the possible points. So what are the possible points? First take x 0, 0. Next point is root 2, 0. And next point is minus root 2, 0. So you will get these 3 points. And on these 3 points, you have to check whether they are minima, maxima or saddle point. So let us see. First test is find the second derivative. What will be this value? This is 12x square minus 8. And let us calculate this value at first at x is equal to 0. So at x is equal to 0, what will be this value? You can see if you put x is equal to 0, that is minus 8. So that is negative value. And also at x is equal to plus minus root 2. Because this is x square, so both will give you positive value. So this will give you 12 plus minus root 2 for both case, minus 8. So 24 minus 8, that is 16. So that value is positive. So at 0 you will get negative, and at plus minus root 2 you will get positive value. And what about y, second derivative? In this case, the second derivative is simply 2. So that is always positive value. So now you have to see, in this case, for given value of x and y, what are the possibility for second derivative? You can see first combination is 0, 0. Then you have root 2, 0. And next combination is minus root 2.
सर ऊपर से दिख नहीं रहा, थोड़ा सा नीचे.
Okay. So you can take it as x and y. So first point is 0, 0. Next point is root 2, 0. And next point is minus root 2, 0. So we have to see second derivative. So at 0, 0, what will happen? You can see this x will give you negative, means if second derivative is negative, it means that is maximum point.
Maximum.
And what about y? Y is positive, that is minimum point. So again at root 2, these are minima because all are negative. This is positive value. So positive is for minima. You can see this is positive and y is always positive. So what does it mean? 0, 0 is saddle point.
Saddle point.
This is minimum point and this is also minimum point. Is it clear? So that is the first case, but sometimes there is exception to this rule. So that's why I have tell you final test is, if you want to finally verify, you have to write this value that I have written. H is, you can see fxx at x naught y naught, then fyy x naught y naught minus this is fxy or yx x naught y naught whole square. So at different point you have to calculate these values. So let us first calculate fxy. What will be fxy? You can calculate because this is del f by del x is this value. So what will be fxy? So this will be del f del y into del x. So further differentiate this with respect to y. So this will be 0.
0.
This is 0. Now calculate at different point. First calculate at 0, 0. So let us calculate at 0, 0. So what will be h? So fxs is minus 8, fyy is plus 2 minus 0. So this value is negative, less than 0. So less than 0 is saddle point. And at other 2 points, let us take at root 2, 0. So what will be h at root 2? So this is 12, 16 into 2 minus 0. So that is 32 plus value. And at minus root 2, 0, again h is 16 into 2 minus 0, that is 32. So they are greater than 0. They are greater than 0, and then you have to see second derivative. So at these 2 points, that is positive value. So both are positive. It means they are minimum. So this is the final test, because sometimes this may not work. For example, let us see next case. Let us see next case.
Sir,
Yes.
सर वहाँ ऊपर x इज इक्वल टू मैक्सिमा टू मिनिमा, इसका क्या मतलब है सर? यहाँ
Means-
x रहेगा या
At for given x, I am seeing the second derivative. According to second derivative, you can decide that will be minima or maxima value. For example, when 0 value is negative, negative means maxima value, and y is always positive, so I have written it minima. And for root 2, this is positive value, so I have written it minima. So when both are minima, you will get minimum point. When one is maxima and other is minima, you have saddle point. When both are maxima, you will get maximum point. That is the condition.
Sir, fxy and fyx different होगा?
F, both will be same. You can check. Fxy is fyx. You will get same value.
Always, sir.
Fxy and fyx will be same value. You can check. You will get 0 here.
So from value of h directly, we cannot decide whether the point is minima or maxima.
No, this will only differentiate with, because problem is with saddle point. This will only differentiate whether you have saddle point or maxima or minima. So when less than 0, saddle point. When greater than 0, it may be maxima or minima. Then you have to see the second derivative, whether they are positive or negative. Accordingly, you can decide whether they are maxima or minima.
Thank you, sir.
For example, next case, let us take fxy. Yes.
सर आपने दिखाया f(x, y) del f del by del x. यहाँ पे del स्क्वायर नहीं है, वहाँ पे del स्क्वायर है.
Del
del स्क्वायर f
del square, del square.
Where is del square?
सर नीचे fxy.
del square f del by del x.
That is del 2y. Del 2y. Now next example is, let's say x square plus y square plus 4xy. In this case, you have to check at 0, 0. This point is given. Let us check it. Let us check whether 0, 0 is maxima, minima or saddle point. So we will check both condition. So what will be second derivative? Del 2f by del x2. So this is twice x plus 4y, and then further differentiate, you will get 2. And del 2f by del by 2. This is 2y, this is also 2.
Yes, sir.
Now what does it mean? Both are positive.
Minimum.
So it means 0, 0 is minimum. But let us check the final test, because this may not be correct. So for final test, you have to find this value, fxy. So fxy is to f by del yx. What will be this value? So
4.
if you differentiate with respect to x, del f by del x is, this is twice x plus 4y, and if you differentiate with y, you will get 4. And you will also get fyx is also 4, because del f by del y is 2y plus 4x. So both will give you 4 value. So now you have to put this value. So h is, fxx is 2, fyy is also 2 minus 4 whole square. So this is 16 minus 4, that is minus 12. So less than 0. It means 0, 0 is saddle point. So that's why you have to always check for final test. This will give you the exact result. So for example, in this case, let's see, if you use only this rule, you will get 0, 0 is minima, but actually it's a saddle point. So just remember this point. Using final test, you can decide whether it is saddle point, minima or maxima value. Is it clear?
H की वैल्यू में 4 कैसे है सर?
This is del f by del x. If you further differentiate with respect to y, you will get 4. So that is fxy. Similarly, fyx, further differentiate with x, you will get 4. So this fxy is 4. This value is 4 at 0, 0. So that will give you minus 12, less than 0. So 0, 0 is the saddle point.